Hello, I am Ernesto Riestra, co-founder at Sync. And apart from being involved in this project that you're going to see in action now on this presentation, I'm also very active in the field of technology and innovation management. And what I'm going to introduce here is a story of how the field of patent bibliometry has evolved into something very interesting that is happening now, and why I think this is one of the key things that we need to put attention because basically it frames the overall global patent system as a system that can be affected very strongly by generative AI and some other solutions that are coming out and being prevalent now. So, and of course, I'm going to be using Sync to display my content here. So, first, as an introduction, the fact is that there's this thing that we call patents and intellectual property in general, and to be honest, patents touch the most important aspects related to human activity. So in fact, there can be a lot of opinions and discussions, but basically the idea that you or the government can give you or grant you a type of temporary monopoly to exploit a certain knowledge or technology is something that enables the whole system globally. So if we didn't have this intellectual property rights, it would be very hard to have the economic evolution that we have today. And of course, this is accelerating. So now I think we're going to be heading a very strong challenge. So what I'm saying is that there's not many discussions online. So either consultancy firms that are working with intellectual property are in denial or are totally frozen because they don't know what to do with AI, or are unaware of what could happen with their core activities inside of their consulting services, inside of their patenting services. So, as a matter of fact, I believe that we're having an existentially challenging potential here. So, generative AI can completely transform the intellectual property world. So now this presentation is also formatted as an essay. So we're going to go through some of these ideas. Why do I believe this? Why do I think that it's going to become a challenge now to have the patent system as we had it before? And it's been evolving for some years already. So it's not anymore the romantic idea that we had from an individual inventor, a solo inventor that could just go with an amazing idea and get a patent and make a whole business out of that. It's a bit more complex than that. So the other thing that's floating around these ideas is the concept of the last human invention. And why do we call it like that? Because AI may eventually replace the overall system that creates and implements ideas and eventually gets them protected. So let's see bit by bit how does this come to be. So I started in 1999 as a student of a very interesting diploma course. So as it happened, the National University of Autonomous University of Mexico had a program to train the future experts in technology management. And I wasn't supposed to be there, but the dean of the school decided, after I saw the diploma program, I actually asked if I could participate, and the answer was no, unless you're going to become or a key expert inside of your transfer office from the school of origin of in this case, the School of Engineering. So I got the dean of the school, I convinced the dean of the school to recommend me to this program, and I had the chance to participate there. And this was my first contact with the whole system of management of technology, and those other aspects that you're not taught about or taught about during your studies as an engineer. So normally, you would just have the technical aspects on a bachelor degree. In my case, it was mechanical engineering, but nothing related to how do you make this a business? How do you, with these solutions, with this technology, how do you convert that into a business? How do you make money out of that? So, and this is what IP rights are about. Is how do you position yourself as to have a barrier towards competitors so that you can take advantage of a certain technology improvement or advantage. During that diploma course, I remember, and it's amazing that this AI generated image is so similar to the auditorium of the Faculty of Science where this diploma course was held, and I remember one of the lectures that was really striking to me. It changed something on me. Was related to bibliometrics. So what was the idea here? And of course we were on a time where AI, there were neural networks already. There was some research on that. I remember a single book in my library on neural networks, but nothing else. And we didn't talk about data science or machine learning or anything like that. So the topic was more probability and statistics. That's the way we called it. And the idea that they floated to us in this lecture was, what if you take the overall records of the patent office, and then you pick the text of each of these patents and then pass that through a process in which you're going to be counting words and their frequencies. So once you have that, why not trying to interrelate these frequencies so that you can start investigating a bit more on this patent corpus. So let's move on to the idea of this patent bibliometrics. So then once I have this, let's say each document that I have will have what we call a vector. And what is a vector? So imagine that for each term that I find on this patent, I make a word count. So let's say we're talking about ceramics. So how many times the term ceramics appears on this patent? And then we see another term called insulator. So how many times this appears, and so on. So once you have a patent organized in that way, then you can compare different documents. So you will say that two patents are very similar if you look at their word counts, and they're also similar. So in a way you can establish what we call an Euclidean distance. So imagine now you want to map all of these patents in a 2D world, on a 3D representation. And what you want is that similar patents appear on a certain region of this space. They're closer to each other because they're similar in their terms. So this is the basic idea. And one of the ways of doing that was multiplying these vectors together and getting a square root, which is the reason why this is called Euclidean distance, because it's just related to standard vectors as we understand them. And then out of this idea, you could have all of these fields of knowledge suddenly mapped in a way. Now imagine that these individual clusters or blocks can also have a tag. So let's say we have a tag that relates all of the patents that display ceramics as a keyword. And then we have another with insulators. And then we'll have some other polymer insulators somewhere, and we'll be seeing all this map with the relation. So we would know that perhaps in the map we can see a higher volume of ceramic insulators than we see of polymer insulators. Now, if you add an extra factor there, an extra parameter, which is time, now suddenly you have technology fields moving in time, and then you could see how certain concepts emerge out of nowhere and start moving around throughout this map. So maybe at some point you will see that ceramics grows and splits from insulators, and then you'll see other applications of ceramics like any types of catalysis or chemical industry applications, while you see as well polymers going into semiconductors or some other field. And this is all moving in time. So this was shown to us in 1999. So now imagine what happens when you kind of move forward with those ideas that were so impacting for me. And now you start seeing what's happening now. So now fast forward to 2024 and you see it's a quarter of a century already. And today all of these concepts have a new way of embodiment or phrasing or terms that appear. So for instance, we have these vector databases that actually in a way do this similarity operations, and then you can have, instead of querying for a specific term, you can build a kind of query of similar terms that are around a certain concept. So this is now a generalized technology. It's all out there and we can use that. And of course we have LLMs, which are much more advanced than all of these word counts that we had at the beginning. So an LLM can do these correlations with thousands of tokens, and this is increasing every month. And it doesn't just apply for individual terms, but you can find these correlations throughout the whole document. So if a certain concept appears, then you can see that maybe a few paragraphs later, and it will make sense for these LLMs. So how do we connect now generative AI with all of these pattern bibliometrics? The fact is that we can have really powerful tools to understand in a better way the whole patent system and see then if there's a space that we can, with our inventions, occupy, or if there's going to be a patent infringement or a certain risk of infringement. So everything looks amazingly promising. Now the problem is that generative AI is not only a tool for doing this bibliometric. Now it's expanding now into what I call multi-layered synergies. So there's many other things that connect to the patent system that are related to AI. It's not exclusively a tool to do research on your patents. Now there's many things that can happen. So now among the ideas are the following. And I'm going to be covering some of these, but maybe not all of them. And some of these ideas are around this acceleration process. How can I use AI to accelerate the process of patent analysis and searching prior art for a certain innovation or an invention? Now, what is the consequence? What will happen with a patent or with an invention if now AI gets involved? That's almost like it's like an ethical question. And the third question, which is for me the most interesting: will AI become, after some time, our last invention? And what does that mean to be the last invention? So we'll see that later on there. So let's move on now, and let's go ahead with this role of AI for doing patent analysis. So the fact is that we can, as I said before, we can have this bibliometric and more advanced models where we can actually today program what is called a RAG system, Retrieval Augmented Generation. And that is the application of an LLM in a secure and private knowledge base. So it's no longer using an LLM out there on the internet, where we know that there's lots of information. Some of them are fake news or from uncertain sources. But if we just restrict our attention to the patent system or the patent records that we have on the USPTO or at the European Patent Office, then we can ask questions about all of these documents. and this is going to accelerate the process of researching what is happening with an invention. So if we have a company coming to us as patent researchers, and it's asking, they're drafting a certain innovation, and they want to know where are the limits now, what kind of risks are they facing, which are the competitors that can or that are moving in their space, and you can accelerate this process, by orders of magnitude. This is something that's happening now. Now, there's this other aspect of what happens when you use AI to generate inventions. So we've seen that AI is already, seeping in the academic world. So there are many. Some of them are, even a bit ironic as well. Something you get to see, and there's some examples there. Hopefully, they're, more and more getting under control. But it's not uncommon to see an article on a scientific magazine that starts the introduction saying part of the prompt or part of the response to the prompt that you pass to ChatGPT. So you see that, that's kind of, strange. But of course, these tools are being used now by academic researchers, by scientists, to draft these, papers for academic journals. So why not thinking about the same thing for patents? And it's obviously, these tools are, of course, being used now into drafting anything that's based on text. So now it's raising now this critical question. What happens when a patent is developed by an AI? And, some of these questions have been already answered. I'm going to show you some references as well that you can research on your own. But the problem is, an AI is not a human. So, this perspective is pretty narrow, and we can, we can actually circumvent it very easily. We can trick the system, in a very easy way. But basically, the idea of, some attorneys is that you cannot grant an AI a patent because it's not a human. But they don't address the question, what happens when a human inventor uses AI to produce an innovation? And this shouldn't come as a surprise. I mean, it's pretty obvious that, as inventors, we can tap into any source of creativity and synergy that we can imagine. So why couldn't we go in a conversation with an LLM to figure out possible configurations of an innovation? So certainly the legal framework is going to need to evolve to address this problem in full. Let's move on now and talk about this other idea of the last invention. So we can think of a progression in time. If you think of the first patent that was granted perhaps in the UK, where the patent system started, maybe it was something really simple, probably was something mechanical, very easy to draw, to depict and replicate. So within that context, there was this idea of the individual inventor, and it was not perhaps something too strange to think. Now, the problem is that the way the patent system has been evolving, first of all, it's accumulating documents that are representing now a barrier. Because once a patent, even if a patent is too old and it expired, but once it was filed there or it was published elsewhere, it's going to present a problem for inventors. Because now if they have something new, it's going to be, they need to compare that to all of those past patents. And as they keep accumulating, eventually you can think of a system where everything has been already invented. This is the concept of the last invention. And it's not, we're not talking about the AI being the last invention. And there's a reason why we think about that, because AI may overtake the task of inventing things. It's going to take that away from humans at some point, perhaps. So that's another idea. But here is the patent system is saturating from inventions, and now what we see is that the individual inventor is kind of a fantasy, basically. No one nowadays, no one is patenting an idea on their own. So most of the work is based on groups or based on researchers that work together, engineers that work together, and of course all of them appear as authors of a patent, but none of them is a single inventor anymore. And of course these groups use some way of creative engine or some methodology. And let's now try to move now to this concept. How do you use the methodology? How do you produce, or let's think of making a machine that generates in an automated way inventions. Is that even possible? So AI could be that in the future. Right now it isn't, but it could become. But this idea is not new again. So there was this TRIZ methodology that something quite before AI or natural language or anything else that sounds, now very innovative. And the concept here was, how do we classify innovation in a set of step-by-step processes? So that my opinion about TRIZ is that it's a methodology where you don't even have to think, too much about the concept. You just pick some TRIZ, pattern, and then try to apply it to your field. And suddenly you see that some things are contrasting, and then maybe something you didn't think about is going to appear in front of you. So it's a very interesting methodology. And let's look a bit on this TRIZ methodology. It was developed by Generative, and he was apparently not only an inventor but also a science fiction writer, which doesn't come to me as a surprise. Sometimes science fiction is the best source for creative ideas, and science fiction gets ahead of what we can actually implement in reality. So the idea here was studying thousands of patterns to find these patterns of innovation, and then once we have these patterns, apply them. It's a lovely idea, I think. Try to systematize creativity, though it doesn't really work in all cases. So the fact is that maybe it could be a way of enhancing the intellectual property system. In fact, now if you think of combining TRIZ together with AI, I can imagine developing a specific GPT engine or GPT instance that is pre-configured with TRIZ, and now you can go into a conversation and say, I have this problem, what do you think I can use from TRIZ as a pattern? And it will bring you out this idea, and it will help you now in this creative process. So that sounds fantastic. The fact is that TRIZ was mainly built around a subset of these inventions. So we see that the patent system keeps evolving, and perhaps some of the patterns that we are seeing today in pharma or in biotech or even in software maybe are not a good match for TRIZ. In my opinion, the methodology seems to be pretty much applied to electromechanical systems, to manufacturing perhaps, and not that much to some more abstract fields where there are if you think, for instance, on monoclonal antibodies. Some of the effects of an antibody or any organic molecule at the end are not obvious, are not evident. So they're kind of emerging features of a specific molecule. It's not something that you can just pass through a certain process or pattern matching from TRIZ, where you exchange certain characteristics and then you get something new. Sometimes you just break up the molecule and it doesn't work at all. And that's why pharma still relies a lot on the process that we know of researching these building blocks that compose all of these drugs and medications. So it's not easy to do, There's some progress, of course, with AI in those fields that's very specific for biotech and pharma, and it's totally unrelated with the kind of the creative process of trees. So on these really fast evolving fields, it doesn't work to stick to this methodology. Nonetheless, it's kind of an interesting idea, and it goes to say that it's not the first time that we're bringing these ideas of speeding up the process of creativity, specifically in the field of patents. So this is happening for some years already. And now I want to make a pause. We've been trying to discuss all these technical aspects. Let's decompress a bit. And you see that on this presentation there are many things coming out of generative AI, mostly the images. But there's also this nice poem that I want to spend some time reading for you. So it's called Reflections of Creation. And of course I didn't write it. So it goes like this. In halls of thought where shadows blend, where human minds and ideas ascend, the spark of genius, pure and bright, births creations from endless night. AI, the mirror, cold and clear, reflects the thoughts that we hold dear. Not a creator, but a glass, through which the light of minds does pass. Yet in its silence, truth does lie. For every code and line implies a human heart that dared to dream, to shape the world, to forge the gleam. Thus patterns mark our journey's start, and AI holds the crafted art. Together they a story weave of human dreams that we believe. So, of course, the prompt was pretty simple. I wanted to have a kind of a poem that relates patterns with inventions, with humans and with AI. And I think it's a nice composition. I couldn't, come up with that on my own. But as I start this segment, as romantic as this poem might be, it is misleading as well. So if you see what the main concept here is, we have a benevolent AI that is actually a mirror, and it reflects. It's a way of bouncing ideas back and forth, and it still thinks from this perspective. It still presents the idea that we as humans are in the center of the universe. So we're the starting point of everything, as usual. But in fact, this is, in my opinion, this is not truth. Just like in other areas, and let's just talk about this example, the Human Genome Project. At the very beginning of that project, they had aimed to sequence the whole human genome. We had an expectation to find a certain number of genes. So scientists were kind of struck when they find out that the project was finished halfway of their expectation. So it's like saying, this is not possible. I mean, humans are so complex and so hard to understand. We're such a perfect creation of nature that it doesn't appear to be right to be so simple. We shouldn't be that simple. And this is happening again with large language models. So what is happening is that top experts in the field are saying, LLMs can't never reach human intelligence, and they will never compete with us. And we've seen that some fields are taken by AI. For instance, no one else thinks today that chess is some activity or some game that we humans can still win against a machine. Today, chess is uncontended. AI and computers are absolute kings in chess. There's no chance to beat them. And I guess certain fields may have this kind of behavior where some specific rules allow them to be better than humans. And it doesn't need to be AI. I mean, you just take a normal automated control system and think of, in aeronautics or in aerospace, you couldn't imagine a human pilot trying to land, a spacecraft without facing some really difficult control problems. So that's why you use automated control. It can react, in hundreds of time faster than a human, maybe thousands of times faster, and therefore it transforms an unstable system into a very stable one. And it's important to have these things on that place and not humans. But there's now a lot of discussion between experts, and they're not really agreeing on this. So there's a good opportunity again that what we call human creativity is nothing else but randomness, nothing else but serendipity. So and innovation is based on that. So how many stories have we heard of inventions that came out of a dream, or walking and seeing something weird during that walk in the park, or imagining something, or maybe even being in a different state of mind. I don't want to say that consuming alcohol, but sometimes you can even think of that. Just by getting drunk, you can get some idea running, and then you go sober and work on that idea. So this is something that happens. And it goes to reinforce the idea that we're not as smart as we believe we are. Most of these things depend as well on randomness. And it's just the only thing we're bringing into this equation is the awareness. So we need to be alert of things that are happening, but let the randomness go. Let this unexpected ideas and knowledge to appear in front of us. So this is what happens with the language models as well. I mean, they turn out to be pretty able to speak to us and creative, and they're started from adding this temperature into the conversation. So if you have very strict rules and low temperature on a language model, it will always bring the same text to you. If you ask something, you give a prompt and it comes out with exactly the same thing. Now you add some randomness to that and it starts sounding human. And I guess, for me, what I take out of that is human brings these imperfections that are the essence of what we do. So it's we're not robots. We're not expected to do things perfectly. We make mistakes. We learn from them, and we iterate. We change our ideas, and this is what brings us forward. So why not thinking of, okay, we're not perfect. We're not the center of the universe, and this randomness can bring things in a better way. So this realization to notice that unpredictability is a core component of creativity. So let's just embrace it. Let's not just put it aside and try to cover that. And now if we think like that, then sorry, this is the next one. Then we can move on now to this idea. Okay, we're not the center of the universe. So that means that AI has a chance as well to outcompete us in the field of patents as well, in the field of innovation. So now let's talk about the end of single inventor. And of course, it reminds me of names like Thomas Alva Edison, or maybe Henry Ford, or these key names of people that maybe I'm not sure if they were the sole inventors for everything they did. Maybe they were just kind of brand name of their companies. Nonetheless, there was still this possibility. The patent system was not saturated. Many of these ideas were not tested. So there was still some headway so that we can try out things. We could explore things, and sometimes we can have individuals, like the Wright brothers, who actually were playing around with the bicycle workshop there, and came out with some concepts that now they probably this is it started like a very humble thing, but now it's what allowed us to actually build the whole aeronautics industry, the possibility of flying, right? And in fact, we're moving out of that period where we had these sole inventors. Now we're working in groups. Innovation is more complex and requires teamwork. And now think of this very gradual process where, imagine now you have a team of researchers in a pharma lab, and they're working on something, and they're using tools based on AI and data science to find out some synthetic chemical molecules. So at some point, there's no line between these tools and the human idea. So you probably don't know when you work, especially with a group, it's difficult to pinpoint who was the original author of an idea. So it gets, kind of merged through the whole group. And I can even imagine that some of these ideas may even come out of the interaction with an AI system. Not only the research aspect or the simulation aspect, but maybe some other creative engine that brings some idea in an unpolished way. Then another researcher, a human one, takes that idea and tries something out, and it comes out well, and then goes back again to the group, and maybe they iterate again. So you'll see how this, what we wanted to see as a very thin or clear line that splits humans and AI, is not going to be possible. So it's going to be a combination of all these things. And at some point, this is going to be as well challenging, again, the patent system. And now let's move on to, for me, one of the, the mind-blowing aspects of this. So, of course, we talked about this impossibility of an AI to file a patent in the patent office because it's not human. But now we're talking about how do you merge AI with humans. At the end, there's going to be an inventor or a name of a physical person, of a human, that's going to be, appearing as author on the file. So there are several of these concepts that can be challenged, but the problem with an invention or a patent, it's going to be granted only if they comply with certain criteria. And there are a few of them. It has to be something new. It shouldn't be something that appeared on a publication, at least on what they call the priority year before you file the patent. So it also needs to be obvious for someone who's a never skilled person in the field of the patent. And now here exactly what they call enablement. You need to be able to explain this to this average skilled person. So it's not obvious, but it needs to be explained. So it can't be a black box that you don't understand as a human. And this opens up a challenge as well, because some of these AI tools are going to be working as black boxes if we don't take care of this aspect of explainable or explainability. So imagine that. Think of what happens on a deep neural network where you are processing images. So even some researchers admit that certain of these layers, a deep neural network is based on many layers of neurons, and some of them are tracking certain features like edges or like vertical lines or like circles. Some of them are more complex, and maybe at the end you can see layers that map a face or an animal, a cat or a dog. But in between, there are certain abstractions there that are hard to explain. You see certain emerging patterns, but none of them are obvious to anyone, and it's hard to explain them to someone that doesn't have the capacity to see the whole thing completely. So those layers are the reason why it could be kind of difficult to use AI fully now, unless this AI is able to explain to humans. And now think of a possible scenario that some experts are discussing is that at some point there's going to be an emergence of what they call a general intelligence. So it's something that some kind of artificial intelligence that can behave as a human and can fulfill not a single task like playing chess, but many tasks. And it seems like we were moving into that direction. But at some other point, there is this concept of super intelligence. So a critical mass of these intelligent agents that is so advanced that it's hard now to decompose and explain to us humans. It's super intelligent. So it's almost similar as if you compare yourself to an ant. So maybe it could be harder to explain to an ant what's the goal of human existence and why do we do this and why do we build
a power plant, and why are we changing our environment so dramatically that now their ant nest is irrelevant, basically. So the question here is, how do we prepare for this scenario? And then there's this other concept that appears that's called AI alignment. And suddenly alignment is intertwined with patterns in a very important way. So if we don't have aligned system that share the same level of values and can explain to us and can be benevolent to humans as well, then it's going to be very hard to combine with our pattern system. So what is this alignment? This is a very important concept. Actually, if you've following up what's happening with the key AI companies in the world, specifically OpenAI, you'll see that lots of these problems with their managers stem out of this alignment problem. So by sacking part of the alignment team from OpenAI, they are making sure they can move as fast as they want. But again, you don't know what's going to come out of that. And there's a lot of people thinking this is not the good way to do it. So it's the wrong path that we're following. What we need to do is make sure that this intelligence systems have the same set of values and intentions. And the irony lies in the fact that not even humans have this alignment. So the reasons why all these guys were, struggling to have their voice heard inside of OpenAI and at the end ended up leaving the company. The fact is that not even humans are able to align their own values as with a single purpose or as a single-minded entity. So it's not that recent, but there's a nice video that I'm putting here so that you can check it later. And this is a debate between 4 experts on artificial intelligence. And I'll let you see the video and draw your own conclusions. I like the discussion a lot because it brings, again, this topic of alignment and why it is so important that we build aligned systems with AI, especially with us as humans. So, final thoughts. I wouldn't say final thoughts, especially because this field is moving. It's not settled down. So there's a lot of dust now. It's hard to say that this is the end game for whatever we're talking about, specifically here with the patent system and innovation. So as you see in this presentation, there are many aspects. So this is multifactorial, as I said, multi-layered, has a lot of effects and causes, and it's not really clear how this is going to evolve. But for me, the takeaway is we need to take a lot of care on these things. I don't think we're doing enough, specifically on our legal systems. I think it's going to probably cut us off guard if we don't make something right now. And specifically, there are many paths, but certainly, denial is not one. And, underestimating these technologies just because, they seem to be, very basic, and we want to stick to this idea that we are special as humans. We cannot be surpassed by something that we invented. And in fact, it's not the case. We are surpassed many, many times and in many orders of magnitude by the things we are inventing. I mean, if you invented transportation method, the car, the airplane, it's supposed to surpass us, not supposed to be less than what we can do. And there's no reason why this shouldn't happen as well with artificial intelligence. So it's something we're designing for that. So just at the end of this presentation, I included this blog. I would love to hear your comments here. If you have access to this presentation, this document with Sync, it's based on a workbook. And as I was saying in this paragraph, there's no final thoughts, but it would be better perhaps to have a discussion together what these ideas are for you. What do you take away of this? Do you agree with some of these things? Or what do you bring into the conversation or the discussion? What is wrong on this way of thinking? How do we make it better? So there's this blog, and of course at the end there's this other widget here where you can give your opinion about what do you think of this article. Is this valuable for you? Was this interesting? Is it confusing? Honestly, I feel kind of a bit confused every time I touch these aspects, but it's okay, I guess. And there's another blog here, the last one, with a few references that's worth reviewing. Yeah, there are some official references from the European Patent Office, and a few of this patent law consultancies that you can also consult or review here, some of their articles. So this, of course, is going to be an ongoing topic, and I'm happy that I was able to share this with you. By all means, if you want to contact me and have additional discussions related to these patents and the impact of AI on our activity as inventors, as creators, please be in contact. I'll be really delighted and happy to be talking more about these things. Okay, thank you, and I'll see you next time with perhaps another interesting topic.